Hi everyone, welcome back to Chem Help ASAP. In today's video, we are going to be working with the pH and the pOH scales and discovering how they both work. Let's get started. The pH scale corresponds with your concentration of hydronium, or H3O+. This is also often abbreviated as H+, which is where the scale gets its name. The pH scale is a negative logarithmic scale, meaning that the negative exponent of the concentration is going to correspond with the pH. Let me show you what I mean. A pH of 1 has a concentration of 10 to the negative 1. A pH of 5 corresponds to a concentration of 10 to the negative 5th. A pH of 10 corresponds with a concentration of 10 to the negative 10th. So you can see how the scale is using the concentration, it's taking the exponent, and it's taking the negative of the exponent. Many of the scales we work with in our everyday life are linear scales, not logarithmic scales. And so the scale of this changes much more quickly than a linear scale would. Let's compare a pH of 2 to a pH of 4. If this was a linear scale, you would expect an increase from a pH of 2 to 4 to correspond with a solution that has half the concentration of hydronium. However, this does not work like that with the pH scale. And it might help if instead of using scientific notation, I switch to standard notation. So a hydronium concentration at a pH of 2 is 10 to the negative second. If we write that in standard notation, it looks like this. Now let's look at our concentration of a pH of 4. That is a concentration of 10 to the negative fourth, but let me convert that into standard notation. Now it may be a little more obvious. Our concentration has not decreased by a factor of 2, but has decreased by a factor of 100. So every time you move a unit on the pH scale, you are moving by a factor of 10. So if we compare a solution with a pH of 10 to a pH of 5, again, the temptation is to say that it's half or 2 times, depending on which way you're going to do the comparison. But this is a logarithmic scale. That is not how it works. We're going from 10 to the negative 5th to 10 to the negative 10th. So if you have a solution that's gone from a pH of 10 to a pH of 5, we have increased the concentration of hydronium by a factor of 100,000, or by a factor of 10 to the 5th. That is a lot more than 2. Now let's talk about the regions of the pH scale. We're going to start right in the middle with a pH of 7. This is considered neutral. This is the pH of pure water. If we are greater than 7, we have a basic solution. And if we are less than 7, we have an acidic solution. The pOH scale works in much the same way, so let's take a look at that. Again, the name refers to what we are measuring, pOH. We are measuring concentration of hydroxide, or OH minus. And this is also a negative logarithmic scale. So the negative of my exponent is going to match with what my pOH is. So 10 to the negative 13 matches with a 13 on my pOH scale. Just like with pH, every time I move a unit on the pOH scale, I change my concentration by a factor of 10. So if I go from a pOH of 4 to a pOH of 5, then I have decreased my concentration of hydroxide by a factor of 10. And if I go from a pOH of 7 to a pOH of 10, I have decreased my hydroxide concentration by a factor of 10 to the third, which is a factor of 1,000. So both for the pH and the pOH scale, just small changes in either the pH or the pOH can often mean very large changes in the concentration. Just like we did with the pH scale, let's show neutral, acidic, and basic on our pOH scale. 7 is still neutral. Again, it is based off the pOH of pure water. If you are greater than 7 on the pOH scale, you are acidic. If you are less than 7 on the pOH scale, you are basic. I hope you found this video helpful, and thanks so much for watching.